Hey guys, today I'm going to try to take a really long lesson and cram it into like under 15 minutes. We'll see what happens. I'm not expecting too much here. All right, so we're going to be evaluating and graphing polynomial functions. I guess it's best first to start off with polynomial functions in standard form. This is not in standard form. So standard form means we're going to go with the variable with the highest exponent all the way down to the lowest exponent. So here the highest one is not x to the fourth, it's negative x to the fourth. So this is going to be negative x to the fourth. The next highest is the negative x squared, so minus x squared. And then the next highest after that is plus 3x, and then plus 2. Okay? And right now we are looking at a polynomial of degree 4. So the degree is 4. That's determined by this guy, right? That's the degree. Okay. The leading coefficient, right? The leading coefficient is -1. Okay. And this is 1, 2, 3, 4 terms. So we're going to call it just a polynomial. Polynomial. Okay. All right, let's do another one here. We have, how about, I'll just 3x squared minus 10x to the 5th plus 2. Okay. So this guy in standard form is going to be this guy right here. So minus 10x to the 5th plus 3x squared and then plus 2. Okay. My degree is 5, that's the highest degree. The leading coefficient is -10, and this is a 1, 2, 3, that is a trinomial, okay? All right, some of the things you need to look for with if you do have a polynomial, okay, notice the powers here are 4, 2, 1, there's an x to the 0 here, okay? So you need to be aware that you don't have a polynomial function, okay, if you see something like this, x to the -4th, okay, that negative power is not cool, okay. If you see x to the, how about something like this, x to the power of 1/2, you're not going to have a polynomial function. If you have something like this, the square root of x, okay, that's not, if you see that anywhere in here, if you see any of these things, you're not going to have a polynomial function. Okay, and also if you have something like this, 5 to the power of x, okay. All right, so if you see any of these things, a negative exponent, a rational exponent, if you see a radical, if you see an x to the power, that means you're not going to have a polynomial function, okay? All right, so one of the things about polynomial functions, you could pretty much tell how this is going to look as a graph, okay? Or if we were to graph this, like this guy right here, the graph of this guy, since it's to the power of 4, we know it's going to be kind of like a parabola in a way, okay? If you have an even power, like the power of 4, the power of 2, okay, your graph is going to look like this. If the power, or the, let's see, the degree, if the degree is even, right, you're going to have a graph that ends in both directions going up. I mean, imagine a parabola like that, okay? The parabola would just be the U shape, okay? It's going to either both go up or both go down. So like if this is if this is negative, so this guy right here is negative, so these arrows are actually going to be pointing down, okay? So if you have a degree that's even, okay? If you have a degree that is odd, okay, your graph is going to have one end of it going that way and the other end of it going that way. Okay, so it could look like something like this. Something like that, right? Okay, this guy could look like this. It could do all kinds of weird things in the middle. Okay, but we'll figure out how to graph those, making a t-chart. Okay, so we will end up graphing something like this, okay, before we're done. Okay. Also, I want you to see that This guy right here, see the degree is 4. It also gives you an idea of the maximum number of times it can cross the x-axis. So right here, it crosses, and right here, it tells you how many zeros you have, okay, how many real zeros you have. This may or may not be the graph for this guy, but it's going to be something like that, okay? So it's just things to look out for, okay? Like this guy right here, the degree is 5, okay? That's an odd degree, so we know it's going to start and end in 2 different directions. And it also tells us that we could have up to 5 solutions, okay? Not necessarily real solutions, just like this guy right here, not necessarily 4 real solutions, but you're going to have 4 zeros. Okay, sorry, I'm a little distracted here. Here we go. Let's just get to the real issue. What we're going to want to do is make a t-chart with something like this. So there's a couple ways we can do this. So let me give you an example here. So part B, we're going to evaluate by direct substitution, okay? All right, so here we have an example. We have something like this. Y equals, okay, 2x to the 4th minus 5x cubed minus 4x plus 8. Okay, all right, and we want to be able to graph this at some point, okay? So watch this. Let me just show you something really quick. We know that if I was to graph this, okay, we know that since the degree is odd, okay, and the leading coefficient is positive, my graph is going to end, okay, in that direction, okay? It's going to probably look something like a parabola. It probably will do something like this. I honestly don't know. I think it's probably going to look something like this. Okay, it's going to look something like that, right? Notice I have 4 zeros, right? Here's 1, 2, 3, 4. Most likely that's what it's going to look like, okay? But I don't really know, okay? So basically what we're going to do is make a t-chart. Okay, so what we're going to do is plug in values. You know when you make a t-chart, you do something like this, x and y, and you have 0, right? And then you have -1 and -2, and you have 1 and 2, okay? But we're going to kind of plot a few more points. So we're going to have 3 and 4, and -3 and -4, okay? And so what you're going to have to do for each one of these points is, I'm sure some of you guys know how to use your calculator, and I'll show you how to do that too, okay? But for right now, by hand, we're going to evaluate with direct substitution. So let's plug in -2, see if we could get that. So it's going to be, if this is f of -2, okay, that means that we're going to have 2 times -2 to the 4th power minus 5 times -2 to the 3rd power minus 4 times -2 plus 8, okay? All right, and so, I mean, we can say f of -2 equals, I mean, I could use my calculator. This will take a second, okay? Let me get out of here. Second quit. All right, so I have 2 parentheses, -2 to the power of 4, okay? Minus, backspace. Let's see, I think I want to go, enter maybe? Oh, no, see, darn it. All kinds of ways you can mess up here. Oh, delete. Where's my delete button? There it is. Okay, so now I can go down. Here we go. Minus 5 parentheses -2 to the power of 3. Go down. Minus 4 parentheses -2 parentheses, and then plus 8. All right, and I get 88. Oh my gosh. Remember how I said this ends way up here? That's right. At -2, it's way up here. Okay, so let's try 0. Okay, let's try f of 0. Okay, we have 2. Okay, times parentheses 0 to the power of 4 minus 5 times parentheses 0 to the power of 3 minus 4 times 0 plus 8. This one's a little easier. F of 0 equals, well, This is 0, this is 0, this is 0. We're just left with 8. Okay, f of 0 is 8. So now you have 8 here, you have 88 here. You're obviously not going to graph that. You're just going to draw an arrow like that, okay, at -2, 88, okay. So basically that's how you're going to start to fill in these graphs by plugging in x values directly into the equation to get the y values. So this is, we're evaluating values of x directly to get the values of y, okay? All right, but I'm going to show you another way you can do this. By the time this lesson is done, we're going to have, oh my gosh, I'm already at 10 minutes. I might have to cut this. I'm going to go ahead and cut this right now, okay? Bye, guys.